In this video, we're going to look at factoring trinomials with a leading coefficient of 1. So an example of a trinomial like this is x squared plus 10x plus 21. Now, standard form for a quadratic trinomial, we call this ax squared plus bx plus c. So the coefficient in front of the x squared term is your a, which in this case is a 1. The coefficient in front of your x term is a b, in this case that's the 10, and your c is 21. And so when we have a trinomial in this form with the leading coefficient of 1, what we're looking for is what two factors multiply to get c, whatever this number is, and add to get b, whatever this middle coefficient is. And so rather than write that out every time, I draw this little x and I say what multiplies to get positive 21, that's my c, and adds to get positive 10. And I'm going to fill in the two numbers here. So if you think about your factors of positive 21 that add to get positive 10, 7 and 3 are the two factors that would work in this case. Now, this is going to break down to two factors. The first term in each factor is going to be an x, because x times x is x squared. If this was a y squared, it would be a y and a y. If it was an a squared, it would be a and a. And then the two numbers that you chose go here. Now, it does not matter which order you put them in, as long as you have these two same factors, x plus 7 and x plus 3. The order in multiplication does not matter due to the commutative property. So if you put x plus 3 and then x plus 7, that's going to still give you this answer when you multiply it back out. And that is in fact how you would check to see if your answer was correct. You would multiply these two binomials together using the distributive property. First, I'll distribute the x. X times x is x squared. X times 3 is 3x. Then I'll come back and I'll distribute the 7. 7 times x is 7x, and 7 times 3 is 21. You see you have like terms here you can combine, and you end up with x squared plus 10x plus 21, which is the trinomial that we started with. So basically we just took that trinomial and broke it down into two factors, that these two factors multiply to give us that trinomial. Okay, so it's really no different than taking a number like 15 and breaking it down to 3 times 5. Okay, 3 times 5 are factors of 15. If we multiply them together, we get 15. So we're just taking, in this case, a trinomial and breaking it down into factors that multiply to give us that trinomial. All right, let's try another one. If we have x squared plus 4x minus 45, then we are looking for two numbers that multiply to get negative 45 and add to get positive 4. Alright, so you might have to start making a list or kind of a mental list of factors of 45. Now this time the 45 is negative. So if you think of factors of 45, you have 9 and 5. One of these will have to be negative for them to multiply to get negative 45. So you're either going to have a negative 9 and a positive 5, or a positive 9 and a negative 5, or if neither one of these work, we'll have to look for some more factors of 45. But in fact, these two do work. A positive 9 and a negative 5 combine to give us positive 4. So it doesn't matter what order you put them in. And when you fill in your factors over here, x squared is going to come from x times x. And then the two numbers we picked are positive 9 and negative 5. Again, you could put negative 5 and positive 9. It would not matter. If we wanted to check, we would multiply these together, and if we did it correctly, it would give us this trinomial that we started with. Okay, so let's look at another one. W squared minus 15w plus 50. Okay, again, I'm looking for factors of positive 50 that would add to get negative 15. If you list factors of 50, I want you to keep in mind they have to multiply to get positive 50. So you have two options. They're either both going to be positive or both your factors will be negative, because a positive times a positive is a positive and a negative times a negative is a positive. Since the term that they, or the number they have to add to is negative, that tells us that these are both going to be negative. So we could have negative 1 and negative 50, negative 2 and negative 25, negative 5 and negative 10. These are all pairs of factors that would multiply to get 50, but we're looking for a pair that also adds to get negative 15, and here it is right here. Okay, so negative 5 and negative 10. All right, that means those are the numbers we'll fill into our parentheses here in our factors. W times W is W squared, negative 5, and negative 10. And again, this is how you would check if you wanted to check. You would distribute those back out, and it should give you this trinomial that you started with. All right, how about x squared minus 5x minus 14? All right, so this time we are looking for factors of negative 14 that add to get negative 5. Okay, because this is a negative 14, we know our factors are going to be, we'll have one positive and one negative factor. So if you think of factors of 14, you have 1 and 14, that's not going to give you 5. How about 7 and 2? Now one of them's got to be negative. If you want this to come out negative, the bigger one's going to have to be negative. So we'll have more negatives than positives, so this will come out negative 5. So a negative 7 and a positive 2. So our factors will be, again, x times x is x squared, x minus 7, and x plus 2. Now sometimes you might have a case like this. Let's check this one out. We're looking for factors of positive 28. Again, that's going to mean that our two factors either both have to be positive or both have to be negative, that add to get negative 7. Since they add to get a negative, that tells us they're both going to be negative. So we have negative 1 and negative 28. That's not going to work. I know 28's an even number, so I know that 2 will go into it, and that will go into it 14 times, but that's also not going to work. 3 will not go into 28. 4 will 7 times. This is all the factors I can come up with for 28, and none of those are going to work. And so in that case, this trinomial is prime. In other words, it cannot be factored any further. And that's just like having a prime number. Up here where I told you that factoring a polynomial is just like factoring a number. You're breaking it down into its smaller parts. And this trinomial cannot be broken down. Just like if I had put the number 11 right here, the only way to break the number 11 down is 1 times 11. And that doesn't really break it down at all because you still have an 11. That's because 11 is a prime number, just like this polynomial is prime. So that is something that can happen, so you have to be on the lookout for it. All right, now this one is going to look a little different because in addition to x's, it's also going to have some y's in it, okay? But essentially we do it the same way. It has a leading coefficient of 1. We're still looking for factors of positive 12 that add to get positive 8. And those would be positive 6 and positive 2. This time though, when we do our factors, to get the x squared, we know we'll need x and x. Our two numbers are 6 and 2, but this last term has a y squared on it, and so these last terms in our sets of parentheses are each going to have a y on them as well. Now, if you're not sure about that, you can always check by multiplying these back together, and that'll kind of show you how this goes back to what we started with. X times x is x squared. X times 2y is 2xy. And then come and distribute the 6y. 6y times x is 6xy. And 6y times 2y is 12y squared. So you see how we got that xy on that term in the middle. So we end up with x squared plus 8xy plus 12y squared. So that is something that you could run into as well with more than one variable in the problem. Okay, let's see if we can squeeze a few more in here. Actually, I meant to make that 22x plus x squared plus 72. So you'll notice on this one that my polynomial is not in order. We always want to make sure our polynomial is in order by decreasing powers of the variable. So we want to rewrite this with the x squared term first, and then the x term, and then the constant, so plus 72. And then once you have it rewritten, we can look for our factors of 72, positive 72, that add to get 22. Now, sometimes these factors may not just come to us right away. We might have to make a list. So we're looking for factors of 72. I'm going to show you a little trick that I learned. I'm going to start with one that I think that everybody probably should know, and that's 8 times 9. Now, 8 and 9 do not give us 22, so 8 and 9 are not going to work, but I'm going to show you how you can take some factors that you know and find some additional factors. So there's a little trick called the half and double rule, and if I take a pair of factors, any pair of factors, and I half one of them and double the other, it'll give me another pair of factors. It doesn't matter which one you half and which one you double. Okay, I don't want to half the 9 because that would give me a decimal or a fraction. So I'm going to half the 8, that's 4, and I'm going to double the 9, that's 18. So 4 times 18 is another set of factors. I can keep going. I can half the 4 and double the 18 and get 2 and 36. That's another set of factors. I already should know 1 and 72 is another set of factors. Now this may not be all of them, but you can do this half and double trick on any set of factors that you have. And if I go back and check, I see that 4 and 18 actually works because 4 plus 18 is 22. So this is going to factor to x plus 4 and x plus 18. Okay, my last one, I'm going to squeeze it in here down at the bottom. X squared minus 24x plus 144. Okay, I'm looking for factors of positive 144 that add to get negative 24. So I want to remind you that when this is positive, both my factors have to be positive or both have to be negative. Since this one's negative, they're both going to have to be negative. Now, we probably all remember from our multiplication facts that 12 times 12 is 144. So that means that negative 12 times negative 12 would give us positive 144 and add to get negative 24. And so when we factor this one, we get x minus 12 and x minus 12, which can also be written as x minus 12 squared. So this trinomial here is actually what we call a perfect square trinomial, because when we factor it, the factors are identical. Okay, So we have x minus 12 squared will give us this. So this is a perfect square trinomial. And that happens when this is a perfect square and we can take the square root of that and double it and get this number. But even if you don't recognize that, it's important here to see, okay, when I have two factors that are the same, I can write it like this. Alright, that's going to be all in this video, but you might want to watch the next video. I'm going to factor some more trinomials that have a greatest common factor that has to be taken out first. So you might want to check that out.